Hey everyone, it's Ross here again. We're back for another session. This week we're going to talk about the QS's or quantity surveyors approach to embodied carbon. And unfortunately, Ilya is not here again. She's still away in that secret mission. But hopefully we will let you know what that is in the next session. But today we have Roger. He's back, and Roger's going to explain the knowledge and experience he has picked up over the last number of years relating to this topic. But Roger, I think you should introduce yourself again, actually, Roger, since even though you're back. Let's go again. Yeah. Make sure everybody understands who you are, you know?
I am Roger. I work for Cosmos. I am a specialist, and I kind of have a couple of specializations in the more rarer and exotic parts of quantity surveying, maybe that aren't touched upon traditionally, but where there's room to grow into them, if you like, or a gap in the market.
And I think embodied carbon has grown a lot in the last number of years, and it's becoming particularly important within the construction industry now. And depending on what country you're in, of course, it's becoming more important than anything else, really. If you take Denmark, for example, you now need a calculation, an LCA calculation done on all buildings above 1,000 square meters, I believe. But maybe you can correct me there.
Yeah, I think it's over 1,000 square meters, and there's a separate set of regulations for refurbishments.
But before we get into all of that, perhaps we need an explanation on exactly what is embodied carbon.
Okay, so embodied carbon is a part of whole life carbon. And as a quantity surveyor, maybe an easy way to think about it is to think of whole life cycle cost, because the two are actually a mirror of each other. So if you look at a whole life carbon calculation, it's broke up into about 4 sections. Section A is the equivalent of the amount of carbon involved in constructing your building. Section B is like the in-building use phase. Section C is demolition. And the D part that isn't very well represented or treated at the moment is the equivalent of recycling and will eventually be carbon offsetting. So the two, the life cycle cost and the whole life carbon, literally are mirrors of each other, and this is why some things like the ICMS format are particularly useful, because they create that direct link between items in the description between the two.
Yeah, that mapping, if you like.
But just to clarify, so embodied carbon is kind of like the vast majority of those items on that list. The only part that isn't is B6, which is operational carbon, which is like the amount of carbon from electrical usage during the building's life. And this has changed over the years. So if you go back to like 80s, 90s and start coming forward, the operational carbon was a lot higher and the embodied carbon was a smaller percentage. But because of the various initiatives and because of the green building certifications, and also because there's a financial incentive to have energy efficient buildings. So if you switch to LED lighting, for example, the business case has improved from your money back, say, within 12 years to 8 years to 7. So operational carbon, its total proportion is kind of shrinking, and what's left is the embodied carbon. And if anything, embodied carbon gets a little bit bigger, because to make a building more energy efficient, you need more stuff. So either your insulation gets thicker or you bring in secondary glazing. So the embodied carbon creeps up a little bit as operational carbon reduces.
And operational carbon also has been impacted by green energy over the last couple of decades, depending on the country.
And this is one of those, it's a thing that's maybe we'll get into later when we talk about, there's a whole nest of issues. There's maybe 2 questions. There's kind of what should I be doing now today? And then there is what you could call the kicking the can along the road problem. Like everybody, like in when we were talking about like economics, they've heard the term kicking the can down the road. There is a huge problem relating to sustainability and carbon, most particularly, where things have been kicked down the road, but instead of a can, it's like a ball of different colored strings, and each string represents a different problem. And it's just being kicked further and further down the road.
And we'll come back to that later on in this discussion, and also in one of our other podcasts on sustainability. But just to come back, so embodied carbon basically is the carbon held within the building material and during the construction of that particular building using that particular building material.
So just as like an example, if you run through section A1 to A3 is the equivalent of the product that you will stick into your building. So the extraction of raw materials, the manufacture process to create your doors, your windows, your metal sheet, your insulation. A4 is the equivalent of the transportation, and then A5 is the carbon to put that all together. Then the B's section is kind of relating to the cleaning, maintenance, repair, refurbishment, recycling. If you're going to repurpose the building, for example, then you get to like the B6, which is operational energy, and then the B7, which is operational water. Then in section C, demolition, transportation, disposal. Disposal breaks down into a few different parts. Recycling, disposal rate breaks down into parts, maybe in terms of what is landfill, what maybe we can get something back from in terms of energy if we burn something. A5 also, in more modern times, A5 has evolved slightly to include something called A5W, which is the waste materials. So, for example, you can extract, because the sustainability guys are often very interested in this part, particularly in the different green building standards like LEED or DGNB. There's points that you can get for reducing construction waste. So this expansion of A5 into A5W is very helpful because it helps you identify the problem materials with a high percentage of waste like plasterboard.
Yeah. And again, we'll discuss the certifications as well under another discussion. So embodied carbon. So then explain to me LCA and WLCA, whole life costing or whole life assessment.
The whole life carbon, like I say, is kind of like looking at life cycle cost. There's a lot of terms like are still the same, like cradle to site, cradle to grave, cradle to recycle, or build to build. LCA can be a bit of a misleading term because in different countries, what goes into an LCA calculation is different. And for the professional bodies like private bodies like LCA, like LEED or DGNB, some of them choose to leave certain parts of whole life carbon out of their calculation, or they will treat section D differently. Two people can talk about LCA and be talking about two different things depending on where they're from or from what context they're approaching. But whole life carbon, WLC, is just everything and maybe a better, more useful term.
So LCA in itself, I guess, hasn't been standardized yet across the globe. People are picking pieces of what suits them better, but WLCA is the entire life cycle process, including everything. So there's no discrepancies or misunderstanding or anything relating to that calculation, if you like.
Yeah, pretty much, yeah.
Understanding embodied carbon, understanding now LCA and double LCA, which becomes very important in the discussion. What is our approach on projects then? Like, how do we as QSs approach our projects in relation to embodied carbon? Starting at the very beginning, if you like.
Yeah. So kind of like at the moment, you get a feel for where the industry is. Like if you go on one of these training courses on how to use one of the different softwares that's available, because that seems to be the default response at the moment of most people is, I will go to software. Yeah. And depending on where you are in the world, certain softwares are more prevalent than other ones. Some people are still using maybe older ones that came out at an earlier time. So it
skewed the information.
It's still a moving landscape. It's not like in the last episode, I mentioned Lotus 1, 2, 3 and as a spreadsheet, and a lot of people are like, what's that? It's like some are quite well established in specific global regions. So, maybe 10 years from now, certain ones will have been stamped out completely in favor of other ones. But when you go into these training courses, you always hear when everyone introduces themselves that I'm from such and such a company, and they always say like one of two things: clients have asked me about this, or internally we are trying to figure out ourselves, what should we do about this? And as I say, the standard response of most people is, I will take software at the moment.
But, to use software, you need some type of information, right? So most software, like estimating software, you need some type of quantification in order for that software to be valuable and to be used to give you an output, right?
Yes, but I'd say the initial problem is you can learn how to use the software, but you need to have a certain background of information to be able to make sense of when is the best time to use the tool, which is the right tool at the right time. And that doesn't seem to be what a lot of QS firms are doing at the moment. My personal perspective is that you should be starting off at business case stage with a manual calculation that you've built up yourself, where you put your own numbers in, and you're building up your own knowledge and background, and you understand exactly how the calculation is put together. And then as you progress forward, it's like a handshake. You can then say, okay, now we're getting towards outline or detailed design. Now I'm going to bring the software in. And the softwares that are available are extremely useful for getting towards that final design, because you can cherry pick the specific product that you want to use, see the specific EPD certificate, you can go for quotes. So you can value engineer perfectly what you need to try and get to where you want to be. But there are some underlying problems with the softwares where they're not ideal for certain circumstances. So for example, in some circumstances, I might be required to create a benchmark to say, if we pretended we were just building a building with no idea towards reducing carbon, what would that carbon profile look like? What coefficients would I use? And I would say a lot of those softwares are not geared towards that for a number of problems, like there is a information bias built into the database of EPD certificates.
Just on EPDs, what exactly is EPD for our listeners?
Environmental
Product declaration.
Yeah, so it's basically structured the same way, with the A sections all the way through to D. Earlier EPD certificates may only focus on a certain specific range, like they may only focus on A1, A3, A4, A5. More modern ones might stretch out and go further.
So the quality of those EPDs coming in from the supply chain are some bit skewed, really. And if you're using those EPDs as the basis for your calculation, then, well, the result is your calculation will be skewed.
There's a huge time and cost impact to getting an EPD certificate. So if you're a manufacturer that has just one product, great, you can get one EPD certificate, it's not a problem. But if you are, so we take an example of a lift manufacturer, you've got a whole range of lifts. You're going to produce an EPD certificate for every single one, or you're going to take indicative ones. And this is sometimes what I mean by I'm worried about information bias in those instances, because if you're Cone, are you worried you're going to lose out to Otis? So you kind of lean towards, well, let's pick this one because I might get a slightly better EPD certificate. The other type of information bias is people who are producing green products. For them, it's almost a sales tool, the EPD certificate. So they want to get it in. Then there's other problems like if you've got electrical panel boards, highly modular, but also highly bespoke. So it's very hard for you to get EPD certificates that are highly representative of that type of piece of equipment. And historically speaking, when people do LCA calculations, if you want to use that term, they like to shy away from the installations and focus more on the core and shell, because that's a lot easier and there's less of these grey areas to concern themselves with.
Well, I guess historically anyway, people shy away from the MEP process in terms of quantification and costing. It's a bit of a challenge in our industry right now from a quantity surveying perspective, I would say, because it's an area in terms of design solutions that's only growing. So like cost, it's a bigger proportion now of the total capex, but so is the carbon. It'll also grow as we become more efficient in the material production for the structure and architecture. We'll have to move towards the MEP services to squeeze out that last bit of quality, I guess, out of the materials that are being produced. Yeah.
We had kind of talked about this before, like about a week or two ago, internally, when I was showing the historical kind of background of where like quantity surveyors come from, where they start off, where the first QS practice you can see exists in time, when the first methods of measurement come in, but then when technology comes in, so you can, or when degrees become formalized, and you can see that like sewage systems, most QSs have no problem measuring rainwater and sewer because they existed before those other parts like degrees and methods of measurement became very formalized. But you can also see that if you look at the percentage of cost associated to MEP and installations, over the decades, it creeps and creeps and grows as we get, like if we just go back to the 80s, how many households had fiber connection for the internet?
Zero, if any, yeah, right? Or even security systems.
And then you come forward another decade, what percentage of homes has solar panels? Then you look at Tesla and you're looking potentially at photovoltaic being introduced into the roof tiles. You're talking about battery supplies in the building. So the IT and the intelligent building control systems just in a normal house just creeps over time. So
then we as, I guess, QSs, our capability also needs to grow, and our education needs to grow to understand how we quantify and calculate embodied carbon within these systems, not just cost anymore. So there's a big transition happening here, I would say, if quantity surveying practices take up this new consultancy role that's now available to them. But if we go back to the projects, then how do we approach this on our projects? When we work on projects and with our clients and with the other stakeholders, I always see that this is a collaborative process. It's not the QS sitting in the corner doing their calculations and calculating embodied carbon. It's very much a dialogue and a communication with the design teams to understand exactly what these solutions are in the early stages. Yeah. If we remove using the softwares right now and go back to the basics like early stage cost planning, cost modeling, carbon modeling or carbon planning, and the very early stages, communication is key there, I guess.
Yeah. And it's on the client side, most large private companies and most public institutions have sustainability people. So there's like four groups, if you like, of four information spheres. So there's like what the average person in construction knows about sustainability and carbon. Then there's the specialists, what they know and how they perceive it. Then there's the public and private bodies. So a public body might be governmental bodies who are enforcing or talking about what the next step in legislation needs to be. And the private example would be the likes of LEED, BREEAM, DGNB. And then there's the universities. And there's quite a gap between the four. And that's one of the threads of string in the ball in the can being kicked down the road.
Is that connectivity. So on our projects, I would say that if approaching this embodied carbon process and taking it on board as a QS and delivering it as a part of your consultancy services, we need to look at how we communicate with our architects and our engineer friends in order to be able to extract that information from their perspective. Because in that early cost modeling stage, you really don't know what the solutions are yet because they haven't been designed, right? So at least in the stage 1, stage 0 in the REBA scheduling structure, So then from a QS perspective, where do you get this information? So EPDs we talked about earlier on a little bit, but are there any websites and databases we can pull information from Embodied Carbon?
If you say you follow the kind of process that we're following, so say you've created cost models, you can generate quantities at an early stage to give yourself quite detailed cost at the very concept level, business case stage. There are, like Institute of Civil Engineers, there are databases where you can take initial starting point data from for your own manual calculation. But then this is where your own research comes in useful, because, like I say, those tools are fantastic for detail. Softwares are fantastic for detailed design stage. But it's almost like educating yourself and helping to educate the clients and the architects and the engineers, because there are potentially, in that ball of string in the can, there's some landmines that you could very easily step on. So you need to be able to do these calculations yourself so you can do the handshake and you can spot where something's wrong. So I'll give you like a specific example maybe. So for example, one issue is like steel. If you say to me, I've got to do a benchmark calculation for what the building would look like if we just used normal materials. If I go to the software, where am I, depending on which software you use, what are they going to assume? Are they going to average out the carbon coefficient of all EPD certificates for that country? Or are they going to do it globally? Because depending on the country that you are in, the average carbon coefficient for each country is dramatically different, because you've got two types of steel. You've got BOF virgin steel, incredibly dirty, high in carbon, EAF steel, recycled, a lot cleaner. Different countries produce vastly different, like China produces very little, and even its EAF steel in China and India isn't so good because they don't tend to use recycled as much. They use a different feedstock, DFI, and it's not historically been the best. So some of their EAF steel is almost as bad as some countries' BOF steel. But then you have to look at some countries import a heck of a lot more than they export. So you end up having to do a lot of these. You have to look at what countries they import from, the major importers, what their profile's like. And when you do this and you compare country to country, you suddenly realize, wow, there's a big difference in what the base case of steel is. And steel's important because when you do your embodied carbon calculations, there's two big criminals, concrete and steel.
Yeah, it's just volumetric, right? They're just in terms of size, but also in terms of how they're produced.
They're kind of mirrors of each other, because concrete is volume. If you broke a building down into just raw materials, heated it up and left it in a pile, concrete as a volume is so much more than any other material. Steel is not that big, but it's the process
of producing steel is the issue.
Particularly the BOF, BF, blast furnace steel. It's an incredibly dirty process, if you like.
And what about countries that have green energy then, that produce a high percentage of green energy? Does that help their coefficient on steel?
Well, this is one of the strings in the can being kicked down the road, because we're getting a bit more towards the sustainability issue here. But yes, different countries are at different states of transferring to green energy. And EAF steel, obviously, if you're in a country with a greener energy supply, is going to be cleaner.
Yeah.
But then there's lots of nuances in this, which is why you kind of need to know it to avoid the landmine, because you can say, great, I'm going to use recycled steel. Everybody gets to 2030 and goes, crap, let's use recycled steel. Where are you getting all the recycled steel from?
It's the same with timber at the moment, right? So if everybody transitioned over to timber construction, where are we going to get the timber from?
Timber is another one of the strings in the can, because everybody right now has this assumption, let's use timber because of the carbon capture.
But also it looks great, right? So when you're saying timber to people that aren't involved in the industry, everybody's looking going, God, it's really green. They have a certification and it's a timber building. Wow, that's great.
Well, it's the sequestration that comes along in Section D that's like a carbon credit. And the assumption is I'm using timber, it's great for the environment.
Yeah.
But one of the strings in the can that people aren't asking is, actually it's not. And this is where I mentioned the 4 kind of spheres. The universities have started to pick up on this. Because what happens is if I cut a tree is almost like an engine for taking carbon. So say it takes 10 kilograms of carbon out of the atmosphere every year. Second I chop that tree down, that's 10 kilograms of carbon that's no longer being taken out. So there's this issue that a lot of people are missing about not asking about forestry and felling practices, because the assumption is, well, I planted another tree.
But how long does it take to get as far as...
If it's a sapling, say it's taking 1 kilogram, and if it's going to take 50 years to reach maturity, you actually end up with a carbon debt.
So for every tree you cut, you need to plant X number just to take that 10 kilograms out.
And again, there's so many of these things that are quite nuanced and complicated, because different trees have a different sequestration rates. And it's normally the trees that have broad, leafy canopies that are the best, because they have more branch and because the leaves drop off. But then there's also the issue of, the leaves deteriorate, so part of it in gases generates carbon, but the liquids go into the ground. So there's little nuances like that. But then there's also the fact that the tree has a natural lifespan like a human being. The optimal solution is, once the tree starts to reach towards the end of its lifespan where it's going to get ill, take less carbon, die, start to release carbon, that's when you've actually trapped carbon. You've stopped it from deteriorating and going back. You've chopped it up. You've put it into your building. It's locked there for 50, 100 years, whatever it is. So this is one of those issues that, like you say, you chop down the tree, you put the sapling. If it's one sapling, you've got a carbon debt over a period of time. Okay, so I plant 4 trees. I plant 6. When do you break even? Then you've got to allow for the mortality rate in the trees, because younger trees have a mortality rate where a certain percentage die off.
And disease, etc., that's happening at the moment, right?
And at the moment, the assumption is, it's just blanket. I'm using timber. That's good. What happens if you got it historically from Brazil, where it's just mass deforestation, no replanting?
So it sounds like, we talk about the softwares and the automation and people just moving towards them. And I guess they're an easy scapegoat currently in order to produce your LCA calculations and conform to what is required by policy, etc. But there's much deeper questions that need to be asked and answered here on our projects. But what if I put to you right now that we have to start somewhere?
At the moment, the starting somewhere is the easy way out. I take software. And it's not a good approach. We have to, if we're going to take on this task, I think the point is that we have to develop a better understanding of what needs to come behind it. Otherwise, we've got no ability to question what's being produced out of the we put numbers into the calculator gave me a number. I tweak it, and all I can say is that's the number the calculator gave me. So we have to, if we're taking on this task, we have to do our research, and we have to build up a larger body of knowledge so that we can question and tweak things, so we can give the best advice to our clients to avoid the landmines. Because one example, when we're talking about the timber, one customer we had not too long ago was saying, well, I want to build with timber, and this would be the largest timber frame building of that type in that country. And that will make us look good. If you got your timber from
locally or wherever.
If you got it from
yeah.
old-fashioned Brazil, where it's just deforestation, 10, 15 years from now, people could be pointing, saying that's the exact wrong way to do it.
Yeah. People should be cautious about the steps they take right now. So just a kind of an analogy on this is extracting quantities directly from a 3D model and without qualifying and verifying that they're correct is exactly what we're doing with carbon right now. We're just extracting from the softwares a figure without really qualifying or verifying. And of course, as QSs, we know the problems we have in our industry right now as QSs. We don't trust the models, the 3D models for our quantification. The only way that we can really trust them is by getting involved with the architects and engineers. So the same principle should apply to carbon. The only way we can trust the carbon calculations is actually to understand how it's calculated down to each material, etc., like you explained for the steel and the timber. That kind of feeds very nicely into our last kind of point on this particular podcast is how does the QS get involved? And I think we've kind of talked about that. Carbon for us, I think, because it starts with quantum, it makes sense that the QS does it, but we can't rely on the softwares to calculate our LCA, because we don't rely on the 3D models to calculate our quantities. A lot of companies are still doing 2D, where obviously us in Cosmos, we're not. We do as much out of 3D automation as possible. So for carbon, we need to get into the nuts and bolts and the bones of what is behind the carbon calculation, right through the whole life carbon assessment.
Yeah. So there's a couple of parts to it. So as you're saying, one side's the quantity issue. How can you get the quantities you need at an early enough stage to do a calculation? Then there is the natural progression of quantity surveying, where we've had this historical kind of space that we were in, and we've stretched out in terms of life cycle and trying to push into the business case side of things, and how carbon is just a natural, particularly with a format like ICMS, is just a natural mirror image of it. So getting the quantities is one side, but the other side is understanding where you get the carbon coefficients, the equivalent of the unit price, the carbon coefficient, where it comes from, how it's built up, and the nuances behind it. Just like as a quantity surveyor, you still have an understanding of construction itself. You have an understanding about how a mechanical system works sufficiently for you to do your task. So if you're taking on this task, there's a background of information that we need to build up to be able to adequately do it and give advice at the earliest stages before a lot of, as we said before a lot of time and expense has been created. And there's a lot of this early stage, you can make big decisions at low costs at early stage.
It's the same as value engineering. The earlier you take it, the better it is, any decision making. Yeah. So the same for carbon. But it sounds like there's quite a bit of a way to go yet in terms of really understanding embodied carbon and how it's calculated. For the QSs out there, I guess you need to start somewhere. Literature is available, but we always say that the best way to investigate anything is on the project.
Yeah. If you're coming in during the design phase, then using the software is fine because you're coming in a little bit later. But if you're trying to get involved branching out for whole life,
at the business case,
the business case stage in particular, where we should be, like kind of in the German market where everybody's constantly talking about like a economic value and efficiency, you've got to be there at the very beginning. So you want to start creating your equivalent of a Excel spreadsheet for your quantitative takeoff, and there are data sources, and you can start with key carbon drivers. So even if you kind of go slightly old-fashioned with the carbon calculations and you just focus on core and shell, and you shouldn't be too uncomfortable because you're going to know the vast majority of it is all going to be in the concrete, it's all going to be in the steel. So if you just then start to do your background reading and research on, okay, what's the position with steel? What's the position with concrete? Because they are the two, you know, if there's a rogues gallery with some mug shots on the wall, they're wanted, then it's steel and concrete, but even that is heavily nuanced as well because they know they've got a problem. So within the cement and the steel industries, there is already their plan moving forward because they don't want to get potentially replaced.
No, exactly. And that's an interesting point, actually. You'll read a lot about green steel and green concrete and green cement and all different additives to replace cement, etc. But there was a good article last week I read on the RICS about this. And if the entire industry shifts that way, it won't be as green as we intended, because we will have to import all the replacement products for cement from other countries, meaning that you have that entire transportation CO2 embodied carbon aspect of it that will subsequently add up to that same level as traditional concrete.
Potentially, but this is where the wider reading comes in, because at the moment a lot of the facilities that they are talking about are kind of like specialist markets in certain countries, producing it, exporting it. So it's not a lot. Some of these countries don't have it domestically yet, but as the demand increases for it, if that's the direction concrete goes, with the clinker replacement is just one option. One that is virtually untalked about is actually direct carbon capture, which basically boils down to the cement industry know that they've got an issue on their hands, so they've been trying different technologies. So if you go to the university literature, you can see that they have listed out all the different experiments that are going on at the moment. The private institutions tend to be too rosy on when these might come out, and most of the universities are saying, no, another 5 years on top of what they said. So direct carbon capture, say 10 years from now, might be something that is very real and genuine. So clinker replacement might phase out, it might carry forward. We don't know yet. But like I say, this is one of those nuances you need to be aware of and be building up in your knowledge base.
Just to come back then on it all, and I think we really dived into some detail on the concrete and steel there, and timber in particularly. I like that one really, because we're really driving towards that, and it's at night with our headlights off, I think, on a road we don't know.
Yeah, and there's maybe one more that I should just throw in there in relation to, or maybe it comes down to a separate one if we're doing sustainability on the green certification.
We'll pick that one up. We'll put that one up in sustainability. But thanks very much, Roger. We covered there embodied carbon, LCA, WLCA, in particularly the projects, really the stakeholder groups and how we get involved, and then from a QS's perspective, where to start. I think it's fair to say the best place to start is just at the beginning. Just start and then see how it goes. It will take us years to build up this knowledge and experience, but also get involved in the softwares that are available, so you know how they work and operate. But thank you very much for today, Roger.
I may just add one point on the end. You do have to start today, because maybe we'll get to it in the next one. This can kicking down the road is so far progressed. When you mentioned what's happening in Denmark, that's the tip of the iceberg of potentially what's coming. People have there's soft and hard scale of being pushed towards what we need to do. And we've had a long period of soft with kicking the can along the road. And this is the tip of the iceberg of hard starting to come. So if you turn your back on it and you don't do something about it, a couple of years' time, you could find suddenly it's on you and you're really racing to try and come up with a solution to provide something for your clients.
So basically policy will drive the decisions rather than clients themselves driving the decisions. So just to explain what happened in Denmark, all new projects that apply for planning permission from the 1st of January 2023 now have to have LCA calculations. Albeit the LCA calculations, as we mentioned, might be quite loose, it's a start in the process of the journey. And this will happen across Europe for sure over the coming years. So it's very interesting. A lot more to talk about on that, but we'll pick it up, some of it in the next podcast episode on sustainability. Cheers, Roger.
Okay, cheers.
Thanks very much for listening. There's a LinkedIn link below in the show notes. We would love to connect with you.
We hope you enjoyed it and have you with us in the next one. Thank you very much.